My God, this is a boring video. I want shooting for making this video.
Trial 1.
Just to give you an idea what's coming up, you've got the frame count where I've done it very crudely at 60 frames a second, so it's inaccurate, obviously. Then I've done it laboriously, it takes a lot longer, at 240 frames a second, click, 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 click. That's just boring, but it's more accurate, I suppose. And then more accurate again, I like to think, was the where I measure over a shorter distance, because the balls lose speed as they travel over 5.5 inches. Measuring over 1 inch, in theory, should get more accurate results. By rights, I think the most accurate result is just measuring the lever frame movement, because that gives us an indicator of the velocity of the balls before they've had a chance to lose any speed. Okay. I only started doing that in the 240 frames a second count. Sorry if I'm doing your and then it's driving me fucking batty, this, as I'm telling you. If you don't want to watch it, you don't have to watch it. You can just look at this summary I'm going to paste up here, so you can just jump to the conclusions very quickly. I'm sure Gary doesn't want to watch it. He'll only want to watch the ones that seem to prove his case. Fair enough, I don't give a shit anymore.
Trial 2.
And if you're asking yourself, what the fucking hell has he wrapped around those balls? It's balloon rubber, trying to make it so it won't skid this time. Turned out I didn't really need to do it. Surprise, surprise. Just rolling them on a rough surface was good enough. So I used wet and dry paper. And that was perfectly fine, really.
Reset. Trial 3. Full ball.
Well, for a start, let's turn it the right fucking way around.
Reset. Trial 4.
And let's make it fit the window. Zoom in on the only bit we're interested in.
Reset. It's trial 5. Half ball. Reset.
This isn't an important experiment, by the way. That's why I've only done 2 trials of each, just to get a rough idea how well it was working. It was alright, but nothing to shout about.
Trial 6. Half ball. You can see that's the ditch. Quick release, because that was making the lever bend.
When you put that big spring there, like I did in the original experiment, the pressure makes the lever bend outwards in the middle and backwards at the far end. See this end, you see? That's me just putting pressure on where the spring would be. I'm not pressing particularly hard either. And the opposite happens down here in the middle, where it would be pushing the full ball. So in the middle, where it would be pushing the full ball, it's bending forward a millimetre or 2. So the far end makes it go backwards. If that was a spring, and now it would make it go backwards about 1 or 2 millimetres. That might explain why the original experiment came out at 1.7. Not sure really. So that's why I chose to put 2 springs in the middle to share the load, so it's not stressing the lever as much. Because then the far end of the lever doesn't really matter. Because thinking about it, if that's the fulcrum there, this part of the lever is a bit pointless. It only has to pivot around that point. I can't see why it matters whether the force is applied there at this far end of the lever, which makes the lever bend, or whether it's just pulled from anywhere else on the lever. Because to my way of thinking, it's being stressed less if it's being pulled evenly across the length of the lever.
Stop, back stop. 18 inches from the fulcrum. That's a quick release. 9 inches from the fulcrum. There's the fulcrum. That's the spring I ditched, because when that was in there before like that, it was too powerful. It was making the lever bend. When I used this, it was making the lever bend when I closed with that. That was the way before. It was making the lever bend just a little bit banana shaped.
Right, I'm going to screen record this, and if anyone's genuinely interested in frame counting themselves, they can do it themselves just by footage of this sort. I'll just play it through. I'm not going to even stop and start. I'm just going to play it through. Laborious as it will be, and it will be laborious. 1, 2, 3, 4, 5, 6, 7. I'm I'm going to speed this up a bit for you.
8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Big arrow pointing to 20 to indicate where I filled in all this information as I went along. 1, 2, 23, 24, 25, 26, 7, 8, 9, 20, 31, 2, 3, 34, 35, 6, 7, 8, 9, 40, 41, 42, 43, 44, 45, 46, 47, 47. I can't count that fast. And again, I'm sure you don't need this much help identifying where I've put the numbers in, but just to start you have. Okay, here we go again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 3, 4, 5, 6, 7, 8, 9, 30, 1, 2, 3, 34, 35, 6, 7, 38, 39, 40, 40. Yeah, I'm taking the piss now, aren't I? Okay, just one ball count now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 24. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 22, 23, 24, 25. Seems fairly consistent, 24 and 25. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. I could say 16 and a half maybe, because that first one I wasn't sure, but there isn't time to stop from the way I'm doing it here. So you get a rough approximation anyway from this. I'm only playing through 60 frames a second footage instead of 240 frames a second footage. Come on. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 16 and a half again, I think. Sounds like I'm in a German submarine being bombed, doesn't it? Das Boot style. The soundtrack is out of sync. I don't know why, but none of my software can handle 240 frames a second footage off a bloody iPhone. That's why some of these less important experiments, I'm just doing a crude frame count at 60 frames a second, or just playing the videos through in slow motion and just doing a quick count, just to get a rough idea. Not worth going to the trouble of sitting there tapping the button 240 times just to advance 1 second's worth of footage. That takes ages, honestly, it really does. It's so depressing having to do it. But I'm doing it to make it look less painful for you to watch. I might speed it up somehow or other, hopefully without me having a squeaky voice, because then you can't hear what I'm saying. Stop moaning in a minute. Calculator up.
I'm sure you all understood every word of that. We're all learning a lot here, aren't we? No. I wish I'd realised earlier that I work faster to music.
1, 2, 3, 4, 5, 6, 7, 8. I've written a lot more here than I planned, so I might as well read it out to save anybody having to squint. So my conclusions are: 1, that the balls are being prevented from rotating during the push phase. If you look at the marks on the balls, you can see this. Due to the grip against the lever itself. After that they rotate freely, and this was later solved by either putting a small piece of tape on the ball to reduce the contact friction, and also the use of round-headed pins,
similar shape to pool Q-tips. That dramatically improved the results and reliability, or by just using plain balls on an abrasive surface. This actually gives the best results and the least complications.
2. The balls obviously slow down over distance once launched, and this is measurable in some later experiments. So results do not necessarily represent the launch velocity, which may be why even the both balls together ratio came out at 2.23 to 1 instead of 2 to 1 in this particular experiment. Therefore, we need to measure really over the shortest distance possible. In practice, the lever movement itself seems worth measuring, as this may be a better indicator of launch velocity. I'm not 100% sure about that, but it appears that way anyway. 3. Faster launch speed with stronger spring helps a bit, but increases the skidding issues and lever bending concerns. So a shorter lever seems worth trying, as this would not only reduce bending, but would reduce the mass, the weight, permitting use of rigid plastic with no need for height guides, which were needed to prevent the 67cm lever lifting during launch, adding to friction. In other words, it wasn't very stable, the 67mm lever. You have to keep adding bits to make sure it remains like a straightforward pushing force, and you don't want it lifting up or bending down or wobbling or twisting. The only complication then being the increased angle of rotation of the lever. That's a short lever, so you obviously have to bend it back at a greater angle to create the same amount of pushing distance. And the need for accurate positioning of the balls with greater scope for error. Yeah, the shorter the lever, obviously you've got to be more careful about the getting the two distances right from the axis, the pivot. Hence the use of round-headed pins fixed to the levers in later experiments for a smooth transfer of power as the lever rotates.
This appears to work well if the 2 to 1 ratio of both balls together is anything to go by. Okie doke, these are just my thoughts.
Right, the next section is just an example of what the next section is just an example of how much difference it makes when you do count at 240 frames a second, pressing the button billions of times. It does make a difference. It is worth it if the experiment's worth it. I'm not sure if it is in this case. Okay, a summary of the more accurate frame count using 240 frames per second footage. So if we disregard this, both balls run trial 1 because that seems like a fluke. Here's a bit of an afterthought. I think this experiment's a bit better than I realised at the time. This experiment's probably better than I realised at first because there's just one result that was throwing the whole thing out. That 199 there was just a fluke. That's the only thing throwing the whole thing out. So if we disregarded that and disregarded any of the full ball runs or the half ball runs, those results come out pretty much the same. It's only that 199 fluke that's throwing the whole thing out. So it's quite regrettable that I didn't do at least 3 or probably 10 of the whole thing. I should have persevered with this because I think it would have given an overall good result if I'd done several runs, but I was a bit impatient to move on to other experiments, other versions of the experiment, and I disregarded this thinking it was a poor result, but it isn't really, is it? Because the actual 2-to-1 ratio for both balls launched together was reasonably okay, 2.07 to 1, and the single balls launched comes out at 1.48 to 1 and lever ratio 1.33 to 1. So really this had the potential to be a good experiment if I'd had the foresight to do at least 3. I can't be bothered setting the experiment up again though, to be absolutely honest. It was such a pain in the neck. If I have to I might, but it looks like it'll only end up proving Gary even more wrong than he already is. 199. I think it probably really does give a 2.07 to 1 ratio. That's probably a more reasonable conclusion to come to. So the following results probably are quite... Oh, I've not amended this yet. Hang on. This is wrong. So that should be 1.51. 1.51 to 1, wasn't it? So I think the most accurate part is this here. The lever ratio 1.3 to 1. Because this is before the balls have been allowed to slow down, isn't it, really? 1.51 to 1. See, I suppose I could measure over a certain distance. Should I do that? Oh, can I be bothered? That looks like hard work. I suppose I should, shouldn't I? Suppose if I replay the footage I've already taken, but only measure at a certain point. I might do that. Just to prove the point that measuring over this flat 5.5 inch distance is unreliable. Anyway. Conclusions. More accurate frame counting reveals an even worse result, but the lever frame rate ratio of 1.33 gives a better indication of actual launch velocity. I think so anyway. Run 1 of both balls together appears a fluke, perhaps poor contact between full ball and lever, or more likely that pesky lever bending problem that I showed earlier, because it does bend a lot more than even I realised. So if we were to disregard that result, which alone would indicate a 2.5 to 1 ratio, then the second trial would indicate a more likely to be true result of about 2.07 to 1 ratio. Okay, should we see what difference it makes when we frame count at the original 240 frames a second? I'm reluctant to do this because it hardly seems worth the effort, but just to see how much different the results are. And I'm also reluctant to do it because it takes ages. You're going to hear me tapping these buttons. For every 1 second I've got to tap the button 240 times waiting for the balls to be released and then start counting. But okay, let's give it a go anyway. At least there's only 2 runs of each circumstance. Look, I'm going to save you having to listen to all the tapping. I've listened to it myself and it's painful to listen to. It's painful to do, but it's even more painful to listen to, I think. So I'll just make it so you just see from when the balls start moving. Okay, so let's go. This is go number 1. You can see me marking it off there. I thought if I marked it off, you can see I'm not cheating. You can see I've not just selected my preferred choice of trial, so to speak. And that's why in other videos you'll see me sticking 1 finger out, then 2 fingers out, then 3 fingers out, etc. So you can see that I'm showing you trial 1, trial 2, trial 3. Shut up, Steve, get on with it. Click. About a minute's worth of tapping cut out. Here we go. Right, my fingers on the button. Don't know if you can just see my dirty fingernail there. Might be on the edge of the screen. Got to be careful not to miss it. Another minute's cut out. There was more than I realised. I will count the lever actually on this occasion, because I've not been counting the lever so far, but it would be interesting to count the lever movement. 1, 2, 3, 4, 5, 6, 7, 8. Well, it was 7 then, wasn't it? Because it's released the lever. Yeah, let's write this down. 7. We've already counted 1, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. That's 40. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. That's 60. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 70. 71, 2, 3, 4, 5, 6, 7, 8, 9, 79 for the half ball. 80, counting the half ball now. 80, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. That's 100. You can probably see now why I didn't want to do 3 runs or even 10 runs. My God, that would be torture. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. It's 120. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. It's 140. Let's speed this up before we all go fucking insane.
160.
180. 180. Americans won't get that. It's an old dart joke. Bullseye. Jim Bowen.
And that's the largest 180!
180. Let's have a look at what you could have won.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19.
19. Was that 199? It's easy to lose count when you do it this way. Well, that's not 2 to 1, is it? 79 doubled isn't 199, is it? For the next one, okay. Read my conclusions. Trial 2. Right, here we go. Are you having fun, ladies and gentlemen?
Pardon me.
1, 2, 3, 4, 5, 6, 7, 8, 7 again for the lever movement. I don't know why I bothered to record the lever movement for both balls at once. It's only relevant when I'm launching the single balls. Then the ratio might have some significance, but
Stop that, doing it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. That's 40, isn't it? That's gone more than halfway, hasn't it? Considering it's... Anyway, 40. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. That's 60. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 70, 71, 2, 3, 4, 5, 6, 7, 8.
8, 78. Well, that bit was consistent then, really. It was 79 before. I've already done 79, haven't I, I think. I've already clicked that one, haven't I, for the full ball. 79. 80. 81.
2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. That's 100. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 120. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 140. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's 150. 150. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11.
12. 12, that's 162, isn't it? That's more like it. 162. It probably would have been better if I'd done 3 runs at least of this, not 2. The first one is obviously a bit of an anomaly. Get your teeth in, Steve. Because 78 doubled, what's that? 80 plus 80 be 160. Oh, that's not too far off. That's fairly close to the 2 to 1 ratio, so maybe there isn't that much wrong with it. Looks like the first launch was a bit of a... Maybe it wasn't in full contact. So we next go then. Full ball next. Full ball.
The soundtrack is out of sync with the picture, so bear that in mind. Here we go, my finger's near the button.
One, 2, 3, 4, 5, 6, 5. Because it's left the lever now, hasn't it? So lever movement 5 for the full ball. That's 1 now. 1,
2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, that's 40. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 60. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 80. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 90, 91, 2, 3, 4.
5, 6, 7, 97. I'm going to say 96 and a half. Not sure about that. 96 and a half. Here we go again. 1, 2, 3, 4. Observe that the ball isn't rotating, is it yet? 4, 5. Oh, I think that's actually 4 really for the lever movement, wasn't it? 1 counted ready, so 1, 2, 3, 4.
20, 40, 60, 80, 90,
90, 1, 2, 3, 4, 5, 6, 7, 8, 9, 8 and a half, I think. 98 and a half. Then the half ball at last. God, if you think this is painful watching it, you want to try editing it. I must be off my fucking rocker doing this. Pointless pursuit. Moment of truth. Here we go. Lever speed. Half ball. 1, 2, 3, 4, 5, 6, 7, 6. 6 for the lever movement for the half ball. That's 1 moved already. So 1, 2, 3, 4, 5. Does it show that I'm losing patience with this? You stood no chance of fevering that count, did you? 61, 2, 3, 4, 5, 65.
Trial 6.
I wish the soundtrack wasn't out of sync. Here we go. Lever movement. There's got a movement then. 1, 2, 3, 4, 5, 6, 6. Again, yeah. You have to concentrate so hard. You stare at it and you feel like you're going in a studying trance because you start thinking, what am I having for me tea? 1 movement already. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 1, 2, 3, 4, 64. Okay, that was consistent as well, really. 64, it was 65 before. That's not bad considering all things. Right, now let's top these up. This is for both balls together. Oh, not the calculator, the fucking calculator. Let's speed this up as well. Zoom.
Are you enjoying yourself? Are you learning something? No, neither am I. Isn't this the most stupid thing that we're doing with our lives? Was it just me? At the moment. That's a roll, fag. I'm speeding up and it still takes forever. What a lot of shit this is.
Oh, I'm back on.
Okay, a summary of the more accurate frame count.
I'm not
Oh,
finished
look,
my
to be honest,
fag.
haven't I slotted this in before I actually did the... I put the conclusion before you actually saw how I did it.
Yeah, fascinating,
'Cause I
Steve.
thought you might be in a bit more of a hurry to see the results to see if it was worth watching. It wasn't worth watching, was it?
No, I agree.
Okay. If you did watch it, well done.
My twin brother. You're full marks for dedication. What I want to do now is, I want to count over a much shorter distance.
Well, if you've come this far, you might as well watch what happens when we measure over a much shorter distance, 1 inch.
Can't wait.
Okay, so this is the result of measuring over 1 inch instead of 5.5 inches.
No, this is the result
Basically,
of wasting
the,
your life.
The balls launched separately gives a very close result to 1.41. Comes out at 1.39 to 1, whereas it previously came out at 1.51 to 1, measuring over a longer distance. So that appears to be a real cause for concern when we measure over too long a distance.
Anyway, in neither case is it anywhere near what Gary predicted or what I got last time. 1.7. Yeah, so there's 1.39 to 1 is close to the actual lever ratio, 1.33 to 1. So that does suggest that this is more representative of the actual launch velocity ratio. Instead of the full 5.5 inches, let's see what the frame count ratios work out to if I only measure up to the 1 inch line. See, up to this line here. I'm only going to speed this up a little bit so you can actually watch it, just to make it watchable, and so you can still hear what I'm saying and you can still follow the count. Right, so we already counted 1, so 1, 2, 3, 4, 5,
6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 15 wants it. 15. So next one, 17, 18, 19. So now I'm checking for the full ball. 17, 18, 19, 20, 21, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 11 I think there. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah, 11 up to the 1 inch mark. Yes, that's 31 for the full ball. Here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I think that was 14 really. Here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 I'm going to say. I'm not sure. Now the full ball. 20. 1, 2, 3, 4, 5. For the full ball, 5. 25 there, isn't it? This confuses the results. I don't know what to make out of this. I'll explain after. You've not got the numbers in front of you like I have, and they don't seem to make much sense. That's 1 now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 I think. 1 counted ready, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I think 16 again, right? It's a bit difficult to tell because I'm counting so fast. 1,
2, 3, 4, 5, 6, 7, 6. That's for the leave movement. You can hear two voices, sorry, because I'm playing back my old recording. Right.
Ready, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 12. Final one. 2, 3, 4, 5, 6, 6. Again, yeah. You have to concentrate so hard, you stare at it and you feel like you're in a sobbing trance because you start thinking, what am I having for my tea? I'm thinking about that now. 1 movement ready. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 11 for that, I think. So, if I do the calculations again. Now,
I don't know if it's because I'm dog tired, but reviewing the footage I've just watched, I can't bloody understand what's going on because I'm listening to two voices. The previous frame count, and I'm looking at the numbers I've written in my third chart for the short distance, and I'm scratching my head thinking, what the hell am I looking at? So, I'm sorry. I think maybe I'm just dog tired. I am dog tired. I can't analyse it. I'm just going to leave it as it is. And if you want to sort out the mess, you're welcome. Like I say, I don't give a shit anymore. It's not like it's the most important experiment anyway. Probably the most important experiments are the ones that Gary thinks support him. You know, well, we can have a laugh at all that, can't we? A separate video. I can't show you too much at once. It'll drive you as potty as it's driven me. Anyway, thank you for watching, if anybody has. The next bit is just what you've already seen, the conclusion part, but like I say, it's fried my brain now. And I'm the one who bloody well did it. Sorry. Okay, so this is the result of measuring over 1 inch instead of 5.5 inches. Basically, the the balls launched separately gives a very close result to 1.41. It comes out at 1.39 to 1, whereas it previously came out at 1.51 to 1, measuring over a longer distance, so that appears to be a real cause for concern when we measure over too long a distance. Anyway, in neither case is it anywhere near what Gary predicted or what I got last time, 1.7. 1.39 to 1 is close to the actual lever ratio, 1.33 to 1. So that does suggest that this is more representative of the actual launch velocity ratio.